morning. My name is Tabanpour, and I'm the president of Nutrient Recovery and Upcycling. And today I'll be introducing you to how we're making sewage treatment self-sustaining and beyond resilient. Currently, cities are struggling to provide sewage treatment for people, and World Bank data shows that there's been a 46% increase in people without access to sanitation in urban areas since 1990. This is something I can relate to because of the trip I took to Guatemala City, where I witnessed the sewage of 1 million people flowing untreated into Lake Matitlan, which is now considered a dead lake. This problem is something that we can see globally with water pollution on a scale that we've never seen before, and disease and death for millions of people. Our team believes that if sewage treatment were self-sustaining, we can solve this problem and alleviate a large burden to the public. And the way we're doing this is by capturing, recovering, and creating valuable products from sewage that could be sold in the market. And the reason we can do this is because sewage contains valuable nutrients such as nitrogen and fertilizer. Our patented phosphorus recovery process can recover up to 62% of the total phosphorus entering a wastewater treatment plant, which is 150% more than our nearest competitor. We also create a valuable phosphorus mineral that's an interchangeable phosphorus fertilizer with any product on the market. We also produce $2 of cost savings for every dollar of fertilizer we produce. Our patent-pending nitrogen recovery technology can recover between 25 and 50% of the nitrogen entering a sewage treatment plant and produces a valuable nitrogen fertilizer. And this is 12 times better than our nearest competitor. It also alleviates the need for millions of dollars in upgrades that a wastewater treatment plant might need. Our technologies seamlessly integrate into existing sewage treatment plants and reduce operating and maintenance costs, and also reduce greenhouse gas emissions. Our business model is based on selling technologies and services to sewage treatment plants, selling fertilizers to agricultural companies, and also working with farmers to ensure that the fertilizers are used sustainably. Currently, we have 3 municipal partners and 2 industrial partners working with us to finalize our commercialization for our pilots. And we expect that by 2025, we'll have 164 facilities installed in the US. By 2020, we expect to break even. And if we install, we selected a target market of 700 facilities in the US that are likely customers. And if we install our process in those facilities, we can alleviate the carbon emissions equivalent to the sequestered carbon of 600,000 hectares of US forest, which is equivalent to the carbon captured by 1 billion trees every 3 years. Our company was founded at the University of Wisconsin-Madison with Professor Barak, Mauricio, Dr. Avila, and myself. We're supported by 3 wonderful employees, and we combine our business, marketing, and science expertise to create a company that serves humanity and the environment. Our next steps are to finalize the commercialization with going to a sale, and then helping wastewater treatment facilities design their facilities in a way that is more self-sustaining. And our ultimate goal is to build wastewater treatment plants that pay for themselves through the resources that they recover. So please support us in our vision to create wastewater treatment or sewage treatment that is self-sustaining and for water purification and resource recovery. Thank you.
Thank you so much. When I introduced you, I thought it was about agricultural runoff, so apologies for that. Okay, good. Yeah. Just checking. You keep this.
Thank you.
What's your economic business case for the technology?
So
in comparison to alternatives in the market?
So there are two of them. One is that the technology itself alleviates maintenance costs, operation and maintenance costs for facilities. So for the nitrogen recovery technology, we expect it to pay off between 4 to 10 years, and then for the phosphorus recovery technology, it's between 3 to 10 years and pay off for the facility. And then in terms of, and then there's a fertilizer that's produced, and that is a cost shared between the facility and our business. So there's sort of this exchange between us and the facility.
At which scale have you demonstrated your process and your knowledge of the costs, the real costs?
Yeah. So we've built a 40 liter per minute pilot, or a rough 40 liter per minute. Yeah, or roughly 10 gallons per minute pilot for both nitrogen and phosphorus. We already piloted the phosphorus recovery process at a sewage treatment facility, and we just got our first paid pilot by a city serving 1 million people in the US. And right now we also got a grant to do the nitrogen recovery process, to pilot the nitrogen recovery as well.
What's your business model related to the phosphorus cell afterwards? Because you produce phosphorus, you produce ammonia. So what do you do with that?
Right, so that goes to fertilizer distributors, and we've connected with a few fertilizer distributors in the Midwest that are ready to integrate our product line into what they produce.
Is this product a drop-in for them, or it's a new product in terms of composition? Or
So yeah, so we're very focused on the nutrient value, and we produce things that are interchangeable with what already is on the market. And then because we're more cost competitive, we can make a profit from it.
Thank you.